Okay then. Let's see what we have going here today. So, the rules for today are we're going to be taking a little bit of a look at TracePoint. And through that course, we are going to have one primary rule, which is I'm going in blind. I really do not particularly know what I'm doing in this case. So we're going to hope for the best and see what we figure out along the way. So for the sake of it, we're also going to be taking notes and turning that into a post sometime later, just so we have a little bit of a recollection of what exactly it is we've been over. So to start out with, let's try and find out what exactly TracePoint is. Now, there was an article quite a while back that I had seen that I didn't entirely understand at the time, but let's take a look back at it. I managed to find it over here, so let's jump over here. So this was a fun little article, and the idea here was that monkey patching, well, that really wasn't much. And you'll see over here on the right that we have a set of notes which we'll be keeping, so let's just give that a title real quick. And this is just, what was that, Typora, which is Markdown Editor. So I'll just be keeping notes over here on the left and going from there. So to start out with, what exactly is TracePoint? Well, the very short version of TracePoint is that it can intercept pretty much anything in Ruby. Now, what exactly that means, I'm not entirely sure. I'll come up with better definition as we go on. But let's take a look back over at this post over here. That's handy. I didn't know Twitch did that. So the premise of this post is that monkey patching is for wimps. We should use set trace func. Now, recently in Ruby, that's been modified a little bit, and we actually have TracePoint. Well, TracePoint Ruby. Oh, and a little cheat, if you take this dash number up here and you just backspace that, it'll bring you to 2.6. So now there's actually a class wrapper around this, but we will get into that later. And sorry, I have a 4K monitor, so it's a little bit hard. So TracePoint is, according to this, a class that provides functionality of kernel set trace func in a nice object-oriented API. And we have IRC people over there, so we'll be nice. Now the question though is that what in the world is set trace func in the first place? Well, that's a good question. So set trace func, Control Shift V, there we go. Establishes a proc as a handler for tracing and disables tracing if the parameter is nil. So we'll notice that it takes a few parameters up here: an event name, a file name, a line number, an object ID, a binding, and the name of class. Let's go ahead and grab the rest of this real quick. And the particular events it has are C methods. So let's say a C method is called, like, let's say puts or something like that, or C return, which is a return from one of those type of methods. Call, which would be calling a Ruby method. Class, which would be the start of a class or module definition. Finish, which would be end of a class or module definition. Line, which would be executed code on new line. Raise, which is raise an exception, and return, which would be a Ruby keyword. So let's just steal this real quick, and I'll clean all this up a little bit later. But for now, we're just keeping a little bit of live nodes just so we have those. should probably figure out how to do multi-cursor in this, but I can't be bothered at the moment, so we'll just do it the old-fashioned way. Yeah, and I know that it didn't quite get C there. And feel free to mention anything as we're going along. So let's take a look back over at this. So we'll notice over here that we have, as mentioned over there, the event name, the file name, the line number, the object ID, the current binding, and the name of the class. Now, what exactly is binding? Well, binding is something that gives us access to all local variables, all local context, and a lot of bad things in Ruby you probably shouldn't be messing with, but that's what makes it fun. So let's see what exactly this is doing over here. It's looking for any type of class name which has to be fixed num, which would be number. It's using the English operator and, which I would not suggest for the sake of this. We should probably be using, and will. Yeah, let's just grab this. So let's just grab the code over here. So we'll notice that we have these over here. Let's change these over to the actual logical operator. There's some issues with precedence that we have that we'll get into later. So we have the receiver, which will be finding out what exactly is self currently. Then this is an interesting one. We can actually get the local variables in the current context there. Inject, well, that's just basically reduce, so for the sake of making this maybe a little bit easier for people, let's go with each with object. Just so we don't have to be keeping track of so much. Now, each with object also happens to change the order of stuff, so we'll have to keep that in mind. Let's see here, I'm gonna give us some space so face doesn't get in the way there. Okay, so what each with object is doing over here is it's implicitly passing this hash right here to every step of it, unlike reduce where you actually have to return the accumulators we're going. So what this is doing is it's getting the local variables and it's putting them into a hash by using binding eval to get that variable name. So we might call it something like var name just so we can keep track of it later. And then this is the interesting part, is we can actually take those arguments and if it happens to be a numeric, which granted, with triple equals it's insanely powerful, but I would probably use ISA because that's a little bit clearer just from a glance. Triple equals is an extra bit of fun we might go into a little bit later. So in this case what we're doing is we're using eval in the context of that binding to basically say the variable name is equal to the value plus 1. In other words, if we happen to add something, we could do bad things to it. So let's grab this real quick and jump over to some code. Okay, and let's see if I managed to screw anything up. Okay, and I'm on Ruby 2.6, so we'll see if this actually works or not. I'm not entirely sure. If it doesn't, well, I guess we'll just switch back to a different version. I guess fixing them is deprecated. let's see here. Well, now that we know that that is actually an issue, let's take this back over here. Right, I guess now that we have that says trace, it's going to do bad things in and of itself. So that's the reason why we have the object-oriented version over here. If we jump back over to browser. So you'll notice that we have the object-oriented one, which is basically making a new trace point on certain things. Well, we also have the ability to enable or disable that. So the problem with what I currently had is it's defined once and it's kind of there. I mean, I don't remember if there was a way to really disable that or not. I mean, we could take a look back at the documents and see if there is a way, but no. Well, if there is, it's not particularly documented. We won't worry about that too much. So let's go ahead and grab this little bit right here and put that at the end here. So granted that, we're probably going to have to work on messing with this a little bit. And let's see how accurate we can get. So I'm just going to steal this, jump back over to some code real quick. I'm going to exit this. That way we have a clean window that doesn't have a current trace point in it. Jump into an editor. And I will warn you, I'm not particularly proficient in Vim, so there are probably better ways to do this, but we won't worry about that too much. So let's take a look back over at the actual TracePoint documentation, which I have over here in another window. So what we're trying to do here call SQL raise. Okay, so let's jump back over to the browser, just see what I'm looking at over here. So TracePoint, gather information specifically for exceptions, which would be why it's using raise there. We can enable that TracePoint. So let's start with this. Okay, so it looks like that actually got exactly what we're expecting, except a slightly different line, which, okay, that was expected. I can't spell. Okay, so now that trace point is gone, so we don't have to worry about that. Ah, right, I should just walk back over to the code. So we can see here that it's about the same as what we expected. We have the conditional over here. Then we have the zero division error, which happened where we divided 0 by 0. We'll just grab this over here. And go back to the docs. So we'll just borrow that for now. So let's see what we have here. Okay. So given that, let's go back and try and play with this. And if anyone knows how to get around set paste, let me know. I'm not exactly very good at that. Okay, so let's say add trace. And for now, just have that be applying to everything. And it looks like trace has a majority of the same methods. So if we actually go back over to the browser, we'll notice that a lot of these events over here look a lot similar to what we had from that TracePoint API from before. So typically what I do whenever I'm messing around with something is I try and look for something which looks vaguely like what I'm trying to figure out. And then I just click on that to see what we're getting. So let's see here. From before, we have event. And if we skip back over here to this, we'll notice that event lines up. So those two names are the same. So that would still be the type of event. We have file. So let's see what we got here. File. Probably line number. Line number of the event. Well, that wasn't quite what I was going at. We don't really need that one anyway. So that would be line. ID, which would be method ID. Method ID is actually the name of the method there. So while we're going down there, okay. So we'll just get these over here. Okay, so we have the event from above that we're looking for. Then file, I wasn't exactly finding. We'll look for that later. Line becomes line number. Right, I have that copied. ID would be method ID. I wonder if it lets me duplicate a line in here. No, oh well. Now, I kind of wish they would have actually used method name on here, but oh well, I think that's probably some type of throwback. I'll have to look into that later. Actually, you know, C code's right there. We might as well take a look real quick. TracePoint, adder, method ID. That's probably a rabbit hole. We don't worry too much about that. And of course, the notes over here are more of just so we have something for later. I'll add some extra spaces there just so we can scroll that down. Okay, so next we have the binding. Let's see what we got over here. Binding, yep. Yoink. So we'll grab that. So we'll return the binding. Oh, one of these days I should do something on binding later. It's actually really fun. Do we have something for class name? Defined class? Worth a try. Oh, yeah, that looks like it. Okay, so that gets most of the stuff that we're doing, except for file name. I'm not sure where file name is. And of course, we had enable/disable. That way, we just have a reference to that. Let's see here. What else do we have? Line number, method ID, parameters. Parameters is useful. I've used parameters in the past to do a few fun things. I'll have to take a look into that. Because proc actually has parameters as well, and those are really dang useful for certain things. Oh wait, path, there it is. That's what I was looking for. That's our file equivalent. Raise exception, return value. Return value might be useful for later, but we don't worry too much about that. Oh, actually, wait. That one's useful, because we had another case up there to where we're using basically the exact same thing with the may bit. Let's go ahead and grab that. Now, granted, I don't exactly do this whenever I'm normally debugging through stuff, but this is just so we have some notes so we can go back and forth between things as we're going along here. So if we take a look back into some of our code real quick, some of this is starting to look a little bit familiar. So now we could say something along the lines of we have the defined class, and just so we have something for later, and no, let's not do that. So this is a little hack that I've used in the past. So this is actually bracketless hash, so that way if I'm ever debugging, I need a name on something, I need to look back and see what exactly I did, I can just see that and I can add a bunch of values to there just to keep track of everything. So let's see here. If trace defined class happens to be, I mean, fixed num has been deprecated, so it's probably integer now. And trace.methodID happens to be add, so that gets us with 2 of them. So we could do that, or another thing, if it's going to be on call anyway, let's just put it up here. Then I'm going to do something dirty and use a mouse and bim. Ignore my heresy. Let's do that because with the method ID, I at least know that's going to be the same. I'm pretty sure it's an integer, I'm just not exactly sure. Okay. So we have that. Now that we have self, we don't exactly have to bother with that. No, actually, there are a couple of things we could use here. You'll notice that we have the binding eval self. Well, we have that binding.self from earlier. don't exactly need that. Then with args, technically we have parameters. I'm not sure exactly what that's going to give us back, but let's see what we got. Let's see here. Yeah, we basically have those already. No, we don't need binding. So we have trace.parameters, each with object that. Let's do that. And get some line breaks just so we can actually read the thing. And I'm telling you, I'm not good with Vim. Don't judge me on this. And yeah, I'm being a little bit wordy as far as that. What was it? Unset paste for Vim? Doesn't matter. I'll just use a spacebar for now. So we have that. Do we still have binding eval? Yeah. Heh. So binding.eval. Oh, that was the next line. I'm getting ahead of myself. Admittedly, I'm tempted to use 2H on here. You know, why not? Let's use Ruby 2.6. So 2H actually takes a block in 2.6, so let's just use that and go with variable name. So we don't need that anymore. We don't need that. So we have the value. Actually, no, let's just grab this. Ha, I do know some Vim still. Actually, we can probably just one line that. Just for the sake of debugging and figuring out where we're at. So that takes care of the section from about 20 to 24. Okay. Ooh, that's close. Option click, by the way, really nice. I forgot we don't exactly strictly have access to binding. So trace.binding.eval. Happens to equal the value plus 1. use a numeric. Just remember to fix nums deprecated, we should probably be doing this. So let's see what we had back over here on this thing. So that's what they're doing, self plus other. Okay, so we have that, we have that. That. Okay, so we have the arguments. We have the method add. You can grab that. I should probably fix pasting in Vim, but I don't feel like it quite yet, so we'll just put that down here. Clean that up later. Okay, let's see here. Yeah. Okay, I didn't put that in the clipboard yet. Oh well. So let's see what we got over here. Actually, I could probably just go over Sublime real quick, which is in a different window. Dirty hack. Oh well. Doesn't matter. If it works, it works. So we'll take that back. Let's see what we got going over here. That way we have a reference of it. And let's see how badly we botch this. I don't think it'll be too bad, but we'll see. Well, let's see if that actually did anything. No implicit conversion of array into string. Okay. Well, we got to define class integer. Okay, so let's just grab that. Oh, array and string. Well, this is what we use puts debugging for. There, just put literally binding not pry in the middle of there. How many binding not pries can we stuff in this thing? Let's see if it'll work without that. Yeah, it does. Good. So extra white space goes away. So we got to there. And you can use binding not pry and pry. So we can enable trace, try it one more time. That's new. Oh, I must have updated it. Okay. So we'll use that. Yeah. Okay. So we're actually in there. We're not exactly at the top level, so it's lying to us. So we have the trace, call on add. That's why we have the method over here. I got some extra space over there. Okay. So we have the defined class, which has to be integer, which we're expecting. Okay. So that clears this right here. So we take those. That's true. What's trace parameters give us? Ah, okay. So it works like actual parameters. Which means that what we're going to need to do is change this to where it's going to deconstruct that and say that. So we'll steal that. Oh, that's a long line now. Oi. Okay. Let's see what we got. So trace binding eval should theoretically work. Let's see. Nope. Did something wrong. Read line is useful. So we put a binding.pry in our binding.pry. Because I like more binding.pry. Oh, come on. Fine. Actually. I'm not particularly patient right now for that, so we're just going to cheat. We'll just extract that out of there, so over here. So that's going to get last value of every one of those, and we'll see if that actually works. No implicit conversion of single string. That's probably what it actually is. Oh, okay. That seems kind of silly. Okay. Whatever. Well, we got our arguments now, so that's what matters. Okay, so we can copy the rest of that. Exit out of that. Got that. Map last, put ours. Yep. Okay. Fine. Oh, so you can actually use Control R to use readline to get kind of reverse search, which is actually really handy. we got that. We have the arguments, and we still have the binding up pry in there. Where did I leave that? Yeah, well, time for a fresh session. Because we have multiple traces on the same thing. There we go. Okay, so 1 add 2 is now 4. Okay, so that does work. So things to remember. I believe in Ruby 2.5. We have that. We have binding out eval is not found. Well, the only reason it worked in the other case up here is because whenever there's interpolation, well, that happens to automatically coerce it to a string. So it looks like that has us with at least most of a case over here. Variable name bars. I guess let's take this step out real quick. We don't need that. We don't need that. One thing I kind of like to do. Nah, I'll leave it alone. I was half considering taking this line and doing something more along the lines of that. That way we can de-indent everything and have a bit of a clear read, but we'll leave it alone for now. So let's take a look back over at the browser real quick. Yep. Actually, let's try something else. You see, I'm kind of curious about trying to make custom wrappers around this. So if we take a look back at this, we'll notice that for the trace point we have to specify some of this stuff whenever we're going through it. What would be nice is if we had an API around it to where we didn't quite have to do that. So let's just say mocking something out to play with it. We could do something along the lines of my trace point happens to have 1. And we'll just pseudocode it. Say something like on method. So I'd kind of like to be able to say something like method name and have that be able to figure out that I meant make a new trace point on basically a method name. Trace method ID happens to be that method name. Let's make it to symbol just in case. give this a function as well. That way that puts us inside the context of it. Let's try this out real quick. So it's going to give us a new trace point on call, and it's going to next unless that, otherwise it's going to yield the trace to the function. So let's give that a try. Let's call it plus trace. So on method plus, we have our trace. Yeah, let's just output some information. Like, let's say, let's call it T because we don't have too much space there. Just do that. Let's enable plus trace, 1 plus 2. Ah, it didn't work. I mean, it's probably a C call. Try and play with on method real quick. If this doesn't blow up my terminal, I'm gonna laugh. There it went. That's the problem with TracePoint. If you enable it on too much, it's literally going to give you everything. Problem is, it's also going through everything in pry. Jeez. Yeah, that's a fun thing about TracePoint. Alright, I could just disable it. Anyway, ignoring that. So that didn't exactly work. Ignore the tea kettle. So we have that. Oh, right, it's on call. So let's take that off. That should do it. Pesky spaces. Because technically plus is a C call. So now we can put it on there. Do that, 1 plus 2. Okay. Fine. Let's just try a regular method real quick, so we'll define that. On testing. Just see if the seam works. I'm not sure why that really returns false. Kind of weird. Aha! It does work. As to why it's calling it 3 times, I'm not entirely sure. Oh well. Let's disable that and give ourselves something a bit more useful. Like stealing this real quick. Let's give ourselves binding pry. So it does work, just not for C methods. Interesting. Okay. So testing 1, 2, 3. What do we got? Name, parameters. I'm at the top level. No, you're not. Maybe would have let me. I didn't think it would. Okay, so we have our parameters, we have everything else, and where we're at right now is right inside this yield trace. So the reason I'm doing this is basically using this as a guard statement to say only happen to do it if this thing. And next is just for a proc saying ignore it, go next. It's kind of like return. Then we're just going to yield that entire trace to this function that we have, which in this case would have been this entire function. So we're inside there. So we could say something along the lines of testing binding eval, and let's say that I want b to equal 20. Oh, right. Silly me. It's not testing as trace. Well, actually, it's T. There we go. And for whatever reason, interesting. Well, not exactly sure what that's doing. I am using Ruby currently. So let's see here. Well, that certainly didn't work as expected. Why exactly is it registering 3 times though? I mean, I get, oh, right. So disable that, and then clear out that. So what we want to do up here, let's get rid of all this, and then if we go back up on our notes, we have the type of event which is going to be useful here. So why exactly it registered 3 times? Because we happen to have call and return. Runtime error not supported by this event. Wonder what that's about. Yeah. Well, worst case, we just take a look at Chrome and see what in the world it's doing. So let's see what we got here. No, I want you to copy this. There we go. Runtime error not supported by this event. No, Ruby. looks useful. Okay. If particular introspection method is not supported, then not supported by this runtime is thrown. Well, that's handy. So let's just keep that in notes. Grab this bug ticket. Just so we have a log of that. So it looks like line doesn't support raised exception, so that's going to give a runtime error. So let's actually grab the, we're going to want 2.6, we can backspace out of that. Grab that. Then it looks like we have that, so let's steal that. If a trace method isn't included in the given events filter, a runtime error is raised. Well, that's no fun. We don't want that. Okay, so time for us to cheat a little bit instead. So we'll just wrap this in a, why do you think my indentation is 4 spaces? Yeah, whatever. That way we can at least get around the runtime error. Oh. Actually, that's interesting. Notice that's sporadic, so that can actually take multiple types. So if we had the issue with call before, we could make C call instead and make that work. That might work. Okay. Was it C call? Let's see what type of events we had. Yep, C call. So that doesn't work. Let's go ahead and play with that. So put out the trace event and the actual error if that happens to happen. So let's go ahead and reuse that. Now we can try it. Okay, so that actually works. So if we take the test trace again, we can disable that. Actually, that's slightly interesting. Network error. Oh, there it goes. So we can trace on a method. Ah, right. So with that, what we ended up having is all the parameters are going through because we're going on call and ccall instead. So you could probably do trace on that. So let's disable the test trace, and then we can say add trace happens to be equal to on method plus just to see if this actually works. No? Well, worth a shot. Not sure why it doesn't work. Interesting. So it should be the same method ID. Well, that didn't quite work as expected. Anyway, so it goes. Let's see here. You know, the nice thing about on method taking a function and yielding to that method with args like arg matchers, and we'll get that function. This is gonna be evil. I'm not sure how many of you know about the pattern matching shenanigans that I've been up to in the past. Oh, now it works. Huh. Screw you too, Ruby. Okay. Anyways. So we know that works, just not how we expected. Interesting. Well, I'll play with that later. In the meantime, let's disable that trace. Okay. So what we want to do is on method name. Okay, so we have trace parameters. Actually, let's make a new method right above here. Extract args is going to take in a trace. So let's get the last, which would be the argument name, and then let's map that again. Which, yes, we could use one map, but let's not worry too much about that. Actually, no, 2H. Because we're being fancy now, see? And forget consistency. So we have the name of that, and we want to do trace binding eval, the name. What this is going to do is give us a hash of arguments. Okay. Oh, I just got all types of bad ideas. This is going to be fun. Okay, so what exactly do we use up here? Trace binding eval, variable name to string, right. Just in case. we have the arguments. And then we're going to do next unless QO Actually, let's get back over to browser. You know what's bad is I can't even remember my own dang gems. Okay, let's look up QO. There we go. Yeah, it's been long enough since I've actually messed with this. I can't even remember some of the API. Oh, yeah, you haven't met red. This is red. See? Yeah, we'll set you back down. So let's take a look at this. We had that. Match statements. Yeah. So we had triple equals. Didn't I give it a match method? Okay, so let's see what we got here. Quo. Public API. Create matcher. Quo matcher's base matcher. At least I documented stuff. Aha, match. Well, let's just test something real quick. Hop back over to code. Okay, so we have QO. So QOA integer dot match A1. Okay, good. Now we're gonna have some fun. Okay, so looking back over our notes. Next, unless QO. A happens to be between the range of 5 and 10. B happens to be didn't I? Yeah, I think I did. I don't remember if I made this work or not. I think I did. Okay, good. I did do that. Fortunate for me, fortunate for me. And C happens to be 0. I did that. Okay, noted that markdown editors are not great as code editors. But I think that was kind of a given. Anyway. That's a nice thing about half composable stuff. Is we can use our above on method tracer to find out if something happens to match something. So we can do on method name trace. So only if it happens to match that method does it actually work. Okay, so let's grab this, edit that, put that in there. Ooh, that would have been bad. Let's put that over there. I don't know why, but that just bothers me. Okay, so unless A is between 5 and 10, B is even, and C is 0, it's going to go next. Oh, right. Actually, technically already had stuff in there. So that's not very nice of me. So let's do that instead. That's a bit nicer. Extract args, trace binding, eval. Yeah. I'll just comment out that old version over here. Next on this arg matchers happens to match arg hash. Okay. Testing A 1 through 5, B even, come on, C 0. Let's just put some superfluous in there. Yeah, it actually worked. We'll just call it test2 trace. A3, B2, C0. Let's see if this actually works. Right. Aha! It does go. So basically, we just pattern matched up against the fact that arguments were there. That's nifty. Can't believe it actually worked the first time. Well, mostly. We won't count the first time. The actual first time. This calls for more tea. You know, you could use a French press for tea. It's actually very handy. Especially if you want to have more than one cup. So that actually gives us something very interesting to play with. So we can extract the arguments, we can pattern match against the arguments. We probably also pattern match against the return state. That might be fun. Okay. So we know there are the different types of events. We know there's that. We know that we can trace on method with arguments like, I don't exactly like the name, but we'll ignore that for now. Okay. Get rid of that. Don't need that anymore. Now, just to prove a point that that's actually doing what we think it's doing, let's change that to 1. Now you'll notice that that's not actually working. Just for the sake of messing around, let's say on method testing, test trace is equal to on method testing. Let's just extract the args for the sake of fun. actually extract the arguments out of there, which means we can pattern match against it. So say that you're debugging an application, you want to know when a method happens to particularly receive something like let's say, for instance, actually, that you should be able to. I don't remember if QO is smart enough to do this or not. We'll see. Let's see here. So test2 trace. Let's just say if A happens to be nil. So we're looking for a case where whenever this method is called, A happens to be nil. So let's add this. Okay, so it actually can catch that. That's interesting. Let's modify this a little bit, because I'm interested where this is going now. Okay, so method matches. Let's use method name. And give it a quo matcher and a function. And we're basically stealing the same thing right here. Except instead, we're going to just be using that explicitly. And since that's a hash, it'll always match against that. Method matches, next and last quo matcher match arc hash, otherwise yield the trace. Okay, that looks right. Let's see here. So we have that. So let's say test3 trace is equal to method matches. Let's go back over to the actual documentation for QO. So we'll skip back over to here. So it happens to work with predicates, objects, yep. I mean, yeah, we could effectively match against regex or anything else, or case statements, or predicates. Hash against an object. I kind of wish I'd give the ability to have any as a key, but that's no fun. I'm not sure if this will actually work. If any happens to be nil, maybe. I don't think it will, though. Huh, interesting. Right, over the code. So what I just did is check if quo can match any key to nil on there. So I don't exactly know if this is going to work or not, which is going to be very funny. I should, because I wrote the thing. Okay, so let's try this one last time. Ah, right. Being able to disable trace is actually really handy. We might as well just test it over here. Oh, that'll work. Okay. I might have to fix that because that could be interesting. Let's see here. So we have method matches, we have on method, we have all this stuff. Except, as we might remember from a little bit earlier, we have see return and return. Now let's see how those worked again, because I don't remember. Okay, so return is return from a Ruby method. So let's make a new method down here. On method return. And noted I'm not going to use this as an ID any longer. That was not a good idea. Probably just going to use Sublime next time. Well, lessons are learned. Anyways. Okay, so we want TracePoint.new on C return and on return. Let's steal this. Oh, let's steal more than just that. Let's grab all that. Not the cleanest code in the world, but it works, so otherwise we'll yield the trace. Let's play with that real quick. Method return, C return, return. Yes, yes, yes. Okay. Okay. We'll just call it a greater than 5 trace. No, actually, let's just say, because we don't technically have conditions on there yet, so that wouldn't be very nice. Okay, so we have the method name. Let's get back over to code real quick here. And let's see here. There's another value over here that's useful somewhere. Where was that? Ah, return value. Yeah, this is not particularly useful at the moment because we're just basically double logging the return, but you'll see in a second. Ooh. That's fun. Undefined local variable or method name. Now, what did I manage to blow up here? That's fun. Okay, so we had TracePoint.new on C return and return that has trace. It begins next unless method ID happens to equal the method name symbol and yield trace, otherwise runtime. Okay, let's just grab all of our stuff real quick again. There's probably a way that we could start joining some of these conditionals, but for now we're not going to worry about that. Let's just have that there as well. Okay. Oh. Well, that didn't work very well. That's why. Ah, man. That did not end well. Okay, so... apparently I still had a plus trace somewhere in there. Oh. Oh, you're no fun. Fine. I'll just do it on one line so I don't have to recall it later. Okay, there we go. And just we have that again. I still can't spell. Okay. So testing 1, 2, 3 has a ret of 5. Okay, and that would be value versus value, so we could probably say something along the lines of method return matches. Okay. On method return. So we have method name there. Then we have the trace in here. We have that. Okay, so on method return, we want to say yeah, let's just use triple equals for now. You could just yield trace otherwise. Let's grab this, hit back over here. On method return method name, do trace, next unless expected match, triple equals or rather matches the trace return value, and then yield trace, but that has to be true. Okay, looks like I spelled everything right. Okay. So test 5 trace is equal to method return happens to match testing. I only want to see if it happens to have an even number there. Then I want to say extract args of that trace if it happens to have an even response. I want to see all the arguments if this happens to return an even value. Okay. So we'll enable that. testing 1, 2, 3 should give us an even value, and that gives us a return value of 5. Wait. What? That's... Oh. Okay. So, again with the spelling thing, A plus B plus B. Dang it. A plus B plus C. Okay. Oh, right. It's not QO, so I can't exactly get away with that. So we'll disable that before we go back to it. So Ruby's not quite smart enough to know what I mean by this. And since I can't technically use an ampersand there because it'll be really mad at me if I do, I'll use this instead. Now we can enable it. Okay. So now if we happen to call that, we'll get back both return value from the test4 trace and the arguments in case it happened to be even. So if we disable test4 trace, we haven't called that again, we're only going to get the arguments back. Now the nice thing here is that there's also exception events. So let's switch back over to this. So we have raise and we have raised exception. Raised exception looks to be... Okay, what else do we have here? We have some stuff at the very bottom. Value of exception raised on raise events. Okay, that might be useful. So on method raise, and then we probably could clean up some of this code, but we won't worry about it late. Quite yet. We'll just copy and paste mercilessly because I'm me and I don't particularly care quite yet. So the event type over here would have been raise events. So on method name, on method raise, yield of that. It's a runtime error, we skip it. So it gives us some interesting things to play with. Okay, so let's go ahead and get that in here. Let's just make a bad method which has A, B, C. Yeah, we'll just give it A and B. I don't feel like typing 3 things. We'll just have it raise heck and end. On the method raise, bad method. Let's take the trace. I want to actually set the equal to something first. Okay, so I want to extract args in case of an exception on here. So let's enable that. Nope. Bad method 1, 2. Supported by this event. Really? Oh, right. I can get the exception, but I can't get the arguments out of it. That's no fun. Okay, cheating time. So, disable the bad trace, and then instead we're going to put a binding on pry here. Because if I want to see inside of it, let's see what we got. So we enable that. We call a bad method. Now we're in a new pry context. So let's see what we got here. Okay, so we have the binding, we have the parameters, we have the return value. Okay, so we have the raised exception. You know, that's pesky that it gives me that, because it should be able to. Well, it gives me the binding. Really? Can't capture the... Fine. Yeah, I was kind of hoping to get the arguments if it happens to have been. Well, that's no fun at all. I wonder if we could borrow that. Oh, right, I didn't switch back to the code. I'll remember to do that one of these days, I promise. So we're doing a trace on bad method to see on method raise if we could extract the arguments, to which it said runtime error not supported by this event. Well, no fun. Okay, fine. So we disabled it, we put a binding not pry in there, and then we took a look through the exception using ls and pry to kind of look at stuff. We get the raised exception, which gives us some information there. We can't get the return value because there's a runtime error. Okay, annoying. We can get the binding, which we might be able to hack some stuff on that. Maybe. I'm gonna hope so, because we can probably borrow the stuff from Fear over here just to see if we can cheat. T.binding eval local variables. So we can get them. Okay, so in the case of this, we have local variables dot map, and so we have the name t.binding dot eval actually let's make this a 2h. That's really annoying that it does that. I might submit a bug on that one. Okay, so we can still get the parameters. We just have to go about it in a slightly hackier, silly way. I might raise that as a bug for 2.6 or 2.7, because I kind of like to get those variables, because it'd be nice to be able to say, hey, my thing just crashed, what exactly were the values whenever it did this? So I suppose if we wanted to cheat, we could go back up here to this method that we had for extracting arguments. And instead of what we're doing right now, we could probably take the t-binding about local variables and just sub that in. Noting that we have that, so we can take the binding, we can evaluate the local variables. So we have the names. We can still technically get the values out. Okay, that would work. Let's take this, let's exit that. So if we did that, so bad trace is equal to extract args there. Now let's try it. Bad trace enable. We can just go. Fine. Bad method 1, 2. Okay, now we can actually get the arguments out of it. Let's see here. So if we were to go back on here, we could do something like, scroll down a little bit. Method raised with matcher function method name do trace okay. So we want to do next let's call it QO matcher, just be clear that's what we're doing. Basically just steal this. Okay, so we have that. Let's give this a try real quick. Now what we can do is do TracePoint whenever one of the arguments happens to be nil. So let's try this. So arg hash gets those. Next unless quo matcher happens to match arg's hash. Okay. Let's disable the bad trace, and then let's say bad 2 trace, and forgive my lack of cleverness with names. So method raised with, let's say they were going for bad method again. And then we're going to do a match against A happens to be nil. And we could just grab the extracted args again. I think quo allowed subtraces, I can't remember though. Okay, let's see here. A nil, B 2. Okay, let's see what we got here. So we have the extracted args, which should be A1, B2. My cheap hacky hack solution. Bad 2 trace dot disable. Then we just go over here. Unless QMatcher.match the R cache. Should work. Enable that. Okay, there it goes. It has arguments. It knows it's nil. Actually, no, let's just yank this. Yank to the end of the line. Put that. Disable that last one just so we don't have a bunch of crap there. Enable that. Call that. Oh, right. Okay, I'm an idiot. So, here's the problem. You kind of have to yield the dang function. That's why. It's always something, isn't it? Okay. So now if we did that, we can disable that TracePoint. That add to trace.enable. Okay, so it looks like we can get that too. So that gives us quite a few interesting little things that we can play with around TracePoint. I think that's probably all we have for today, but I'm going to probably see about summarizing a lot of this in an article later, just to go back over everything, kind of see where we're at, what all we ended up finding, and we'll see where we go from there. In any case, it's been nice chatting with you all. Have a good weekend.